Cool. So we'll try these predictions and I'll share my screen with you. If I can try to figure out how to do that. Okay. Okay, here we go. So this is what we went over the last time with making predictions. So we looked at how we used the band to make a prediction, and also how then we could break it up into groups to make a prediction again. So what we can do is, I'll just minimize this, we can just go over some of that again, and I'll just make another page here. So predictions for today. Now I'll just make a graph. I wasn't sure that we were doing this. Let's have a look here. It's a grapher. Okay. So remember when we go into NZ Grapher, we type in the Linfield folder, and we'll go into sports science. And again, I'll use the height and weight example that I've just been using. So height versus weight. And I'll put in a regression line here so we can get the formula. Oh, has my screen gone away? Okay, yep, that's been happening. I don't know why. Okay, cool. Thanks for telling me. Right. Let's see. How's that? I think what happens is if I tab like between things, it only sees the first one that I've shared, so I have to remember that. Okay, so I've just made a graph, and what I'll do is now I'll share it again and pick this one. So you can see OneNote now, hopefully. Cool. Right. So what I've got here is my initial graph. And what I would do is I want to, of course, first do my analysis and talk about all of that. But when I'm up to making predictions, first thing I'm going to do is make predictions using this first graph, right? So when I do that, obviously, the first thing I want to make sure that I'm doing is making an interpolation, right? So I want to make a graph, make a prediction from within my data set. And that's important because, of course, extrapolating, which is taking a prediction from outside of my data set, that is dangerous. So if I try to make a prediction for some athlete who has a weight of, less than 30 kg, I'm going to get someone, according to my model, with heights that are, starting to get lower than 150 centimeters, 140 centimeters, as you get lower and lower, which is starting, as you go lower and lower, it becomes more and more unrealistic for someone to actually be an athlete at the Australian Institute of Sport and be, that made up of that makeup, right? And also, as you go very low, of course, you're going to be weighing 0 kg and be 0 tall, and even more, you're going to be negative, which makes no logical sense. It's impossible, right? So this is why we don't extrapolate, which is going outside of the data set. And of course, the other way, if you go the other way, it also doesn't make sense because, again, slightly outside doesn't make sense because the athletes are more in shape, so they don't, weigh a certain weight, or they have to be a certain weight to compete in their sport. And of course, if you go more outside human physiology, they can't be a certain height because humans aren't that tall, and can't be that weight because it's impossible. Okay, so this is also something that you can discuss in terms of predictions, how we only interpolate, which is predict from within our data set. We don't extrapolate, which is going outside, and this is why. And of course, you would talk about the context as I did. Okay, so you're also going to predict for a point that makes sense from within your data set, and you can pick one or two. So I might pick something like 70 kg to predict, okay, which is here. And when I do that, the first thing I'm going to do is I'm going to use my equation to do that. So I have that my height equals 0.54588 times the weight, which is 70, plus 139.16. Okay, where's my calculator? I'll just do that quickly. So that gives me 0.54588 times 70 plus 139.16 gives me 177.3716. Okay, so what I would do is I would actually say what that means. So I would have to say, I predict, that an athlete with a height, with a weight of 70 kg would have a height of approximately 177.4 centimeters. Okay, so hopefully that makes sense. So that part is just the first part that we do, right? And we've done that in the booklet, and that part's just pretty straightforward. We're plugging in one value, getting another value, and that's what our model is predicting. So in essence, we're not really predicting it, like the model's predicting it. So we could even say here that the model is predicting this value, okay? So the next thing that we would like to do is we want to say how confident we are in these predictions. So there are a couple ways to do that. So the first way is to just look up at what we've predicted. So we're looking up here at 70 kg. And if we look straight up at the model, right? So this right here is what we've predicted, right? The model, if you look straight across, well, I can't really draw a straight line. I'm very bad at that, but you get the idea, right? If you look straight across, okay, the model has essentially gone up and across exactly and said, right, if you are just using this regression line, that is what I predict that the athlete will be, right? However, as you can see, there's lots of scatter around that point. So all of these could be potentially what that athlete could be too, right? There is essentially a range of what that person could be in terms of their height if they weigh that, right? So if I draw a line that goes around the scatter on this side, well, pretend it's a line, right? So that's one line, and there's a line on this side, right? Okay, so I've just got a band of scatter. I'm going to make this side a little bit better. Okay, so, okay. So really, I'm trying to encompass about 95% of my scatter. And if you look back to last year when we talked about confidence intervals, right? And you looked at your box plot, right? And then you talked about within that box plot, you had, you know, confidence intervals within them, right? And you're talking about, oh, I think that this will be about 95% confident, da 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 da, right? Yep. So this is essentially what we're doing again. We're saying, well, this is a range in here. And because I've got about 95% of my points encompassed within here, I think, well, I can predict that if I now follow this line up, oops, sorry about that. I'm trying to click things and I clicked the wrong thing. Okay. I need this to go over here, so I can click that. Okay. So if I now can follow this line up and then go across, right? That will give me a prediction for the bottom value that I could predict for at 70, right? And then if I followed it up again and went across, that would give me the very top value that I am predicting, right? And of course, the value that I initially found with my equation, of course, that should fall between those two values, right? It should be in the middle, really, of those two values. Not exactly in the middle, because of course, the lines that I've drawn, they're just an estimation, right? But it should really be in the middle. It shouldn't be, right? So it should fall in the middle, say, of these 2 points, okay? So now what I can say is, this is about 163, right? And this one is about 187, right? Okay, so although I have, predicted something from my regression line, now I've got a lot more information, yeah, about my prediction. Now, the reason that we do this is because depending on the strength of the relationship, I could have a scatter graph, right? That's got scatter that looks like that, and it's a really strong relationship, right? And I can have my regression line, and then if I drew my band of scatter, it's gonna, whoops, yes, I'm really bad at those. It's gonna be really strong, right? The relationship here. And if I tried to make a prediction, that range that I have in the middle is going to be really a small range. But then I could have another scatter graph that has a less strong relationship, right? And then if I have my regression line and my band of scatter, then what's happening here is I have a far bigger range of predicted values. So even though this might be the exact same value, look at what happens. I have a huge range of values in number 2, and in number 1, I have a far less range. So by making this band of scatter, I'm really talking a lot about how confident I am in my prediction that I'm making, right? So in the first one over here, I'm way more confident in my predictions, right? I'm confident in the predictions, right? There's a smaller range for my Y values, right? And in number 2, I've got a much larger, what am I trying to say? Much larger band of scatter, right? Which means that I'm far less confident in my prediction, right? Okay, hopefully that makes sense. So if we go back to our example, we can now add some more information, okay? We can now say, I would expect that my prediction, well, maybe I would say something like, whoops. Although I am not fully confident in these predictions, I would expect my prediction to fall, whoops, somewhere between a prediction of 70 kg to fall somewhere between 163 centimeters and 187 centimeters. Okay. Cool. Does that make sense? Cool. So that is the first part. The second part is, of course, if you then want to go on to break up your graph. So, of course, right here, we've now gone through a whole lot of information. We now have extracted, and this, you're now looking at, merit and excellence instead of just the first part, which is you're just looking at, achieve level. If you now are looking at doing your band of scatter, you're now looking more into merit. And then if you sort of expand it into the next part where I'm going to show you, it's looking at more excellence. Okay, so the next part that we want to look at, and I will stop so you can look that I've gone back into NZ Grapher. And then I'll reshare it with you. Let's have a look. There we go. So the next part we want to do is we want to split the graph. Okay, so this is an excellence skill. And by splitting the graph, I mean you want to now look at it in terms of a third variable. So you might look and say, okay, well, the height and the weight, that's all really interesting, but I want to see if anything else comes into play here. So maybe if I colored it by the different sexes of the athletes, are there any patterns? You know, you might look at the different sports, too many sports, you might color it by different variables, and then, obviously I already know that the different sexes of the athletes, it shows me a pattern, right? All the female athletes are more toward the left-hand side of the graph. They have lower weights, and the males have higher weights, right? Which kind of makes sense because male athletes, they tend to need to bulk up more. They play more sports that they need to train their muscles more. And whereas female athletes, they're doing more cardio a lot of the time, right? Where makes them a little bit more leaner. Okay, so and sometimes they're shorter as well. So what happens is you get this sort of correlation happening. So what I can do now is I can go down to variable 3 down here in the left hand side of my graph and split the graph by that third variable. So if you just notice the correlation here first, you have the correlation coefficient of 0.78. If I split the graph, you'll notice that it's quite different, because usually when you split a graph, you get at least one of them is stronger, but in this case, both of them are weaker, which is worth noting as well. So what I'll do is I'll just, again, put that graph into OneNote so we can have a look and do something with that. There we go. Okay, so again, you're going to go through your whole analysis again. So I'm just talking about predictions today, but it's just worth noting that you would now again go through the analysis, and the key thing is that you're going to compare. It's very important to compare when you split by a third variable. So you're wanting to make comparisons between these new graphs and your original graph that you had up here, okay? So your two graphs that you've got, okay? You've got, you can talk about the gradients, you can talk about how strong or weak your relationships are, which I started to discuss looking at the correlation coefficients. You can talk about the association, the scatter, the groupings, the outliers, right? And the trend. You can also then make a prediction, which is what we're going to talk about for each of these graphs now. So what you're going to want to do is make a prediction for the same explanatory variable, which is 70. Okay, we predicted at 70 for the first variable, so we're going to want to predict at 70 for this variable, for this graph. Okay, so we're taking these new equations and we're going to plug in 70 to each one of these equations. So for the female graph, we have that the height equals 0.5317 times 70, which is the weight, plus 138.55. And for the males, we have height equals 0.42458 times 70 plus 150.47. So I'll just quickly do those and grab those predictions. So 0.138, oops, and 0.424 plus 150. Okay, wait a minute, I've done something wrong. Is that right? Nope. 42458 times 70. Oh, because I did 150 plus 47. That's not right. Haha. 0.47. Good. See, so what I've done is I've got something like 200, and I realized it shouldn't be 200, it should be 180 or 170. So if that happens, you can realize, oh, I must have typed something wrong. So this one's 180.19, and this one is 0.5. There we go, 175, which makes sense because this one is, again, on the bottom half of the graph. So if you go up and across from the line, you should get something that is a lot smaller than if you go up on this graph and then across, right? Okay. So here we go. We'll just write that. I predict, or the model predicts, I'll do it that way this time. The model predicts that for female athletes from the Australian Institute of Sport, that weighs 70 kg, she will be 175.19 centimeters tall. And the same thing here for a male athlete that weighs 70 kg, he will be 180.19 centimeters tall. Okay? Right. Now, the important thing, remember, is to compare. So not only do we want to compare to each other, but we also want to compare to our previous model. So how does that compare to 177 kg? And how does it compare to each other? So I think in this case, it's good to compare to the previous model. So this shows that the females graph predicts a slightly lower value than our initial graph, whereas the male graph predicts, whoops, where's my chat bubble? Oh, did I forget something? The thing said 0.53517. Okay, hold on. Oh, okay. 53517. Okay, it gives me 176. Cool. Thanks, Michaela. 176.19. 0.01. Cool. All right, so still, this shows that the female's graph predicts a slightly lower value than our initial graph, whereas the male graph predicts a slightly higher value. Okay. Probably the model from the female's graph, whereas the model from the male's graph predicts a slightly higher value. Okay. And then it is also comparing them to each other, because obviously if the one is lower than the initial graph and the one is higher, obviously then one's higher than the other. Okay? So that is a very important statement, because you are now making a comparison. Whereas if you are just making the first two statements, you're just doing the same skill as you've done before. So the third sentence that we've written is really important, because now you're looking at it in a deeper way and you are now comparing. Okay? Now, the next thing that we're going to do is we're going to make our band of scatter. And again, I'm going to do this a little bit quicker now because we did it in the last graph. Okay? So my band of scatter will go around about 90%, remember, of my scatter. And you can do this a little bit better than I am, of course. So you'd probably want to draw straight lines instead of just a sketched line, but I'm sure that you'll have a little bit more time and patience to do it. And I'm just showing you the skill at the moment. So again, if you go up and across from each one, you will find yourself a value. And again, it's just a prediction. This part of the predictions, you are just looking for an approximation. So it is okay. It doesn't have to be exact. There's no formula for it. You're just, again, looking for an interval, right? A broad interval, okay? So even if you did do something like this, it would be acceptable. Okay. So again, we can see that, well, first we'll find the values. So this is about 164, let's say. And this one we've got about 188. Here, 170 and 190, right? So now I will type. We cannot be completely confident in our predictions. However, I can be certain that, well, I can be fairly confident, fairly certain that my prediction for the female athlete's weight of 70 kg will fall somewhere between 164 centimeters and 188 centimeters. And my prediction for the male athlete weight of 70 kg will fall somewhere between 170 centimeters and 190 centimeters. Okay? Now, that becomes really important as well because look, I've got so much to compare again. Now, if you look at those two intervals, one is larger than the other. Okay, it's not a huge amount larger, but it is larger. Okay, um, so again, now we can talk about that. The male's interval, prediction interval, is larger than that of the females. This could be because the correlation coefficient, well, because the strength of the relationship is weaker as backed up by the correlation coefficient. Okay, this means that I would not be as confident in my prediction, the prediction of the male's graph compared to the prediction made in the female's graph. Okay? And this is a really good thing for us to make a comparison about because, I mean, the whole entire report that we're writing is essentially coming to this point, right? It's culminating with making a prediction, really. I mean, it's about the strength of the relationship between the two variables. It's about looking to see if there's a relationship, but essentially, it's for the purpose of making a relationship, making a prediction, you know? So, this is an important thing for us to discuss. Okay? So hopefully this has been helpful. Of course, there's some other things that we can break off to from here, but I think this is a really good place for us to stop and for you to digest this information. Cool. Any other questions that you want to ask or something I haven't touched base on? Or are we feeling okay now? Thumbs up or down or cool, awesome, I'm glad. Good. And Z-grapher won't let you see the equation. Okay, so have you pressed the little tick box in the bottom that says regression line? So